Okay, welcome to online biology lessons. Today we're going to look at the full central dogma of biology. We're going to take, hopefully, a small section of DNA, so you gotta imagine that this goes on both ways forever. We're going to run it through its full process of translating or transcribing into RNA, and then translating at the ribosome into a protein, or at least a short protein sequence. Let's see what that looks like. So RNA polymerase goes around searching DNA strands, searches along the DNA strand for what's called a start codon. Codons are a set of 3 nucleotides that when you read them together, and with your codon chart, either code for proteins or starts, or amino acids or starts and stops. In this case, this RNA polymerase finds this TAC start codon, and it starts to unzip the DNA strands just in one section, whereas helicase unzips the whole thing. RNA polymerase is just unzipping one section. It keeps going until it hits a stop codon, which in this case is ATC, and then it stops, and this section is now free for RNA molecule to come in and make a copy of just this section. This DNA would still be, it's kind of like open in the middle, so this wouldn't quite disappear, but for my ease, I'm going to make it kind of move off to the side. RNA would come in and start making copies. So one at a time, it would come in and make a copy of the DNA strand. Then when it reached that stop codon, you would have an mRNA strand that can now leave the nucleus, since it's smaller, and head off to the ribosome to translate into a protein. So it would leave the DNA, head off into the abyss towards our ribosome on the ER outside of the nucleus. Your ribosome will recognize that start codon once again, telling it to start making a protein. Then it would look for these matches right here that bring in the proteins. So we have these small sets of codons matched up to proteins, and you would just match up the AUC would be our first amino acid that we're looking at. You'd use your codon chart to look for the amino acid, or I actually have these already paired up. AUC would end up being T or UAG. So UAG over here is MET, brings it in, forms your first bond. Then it keeps moving forward, so the ribosome moves along. Next one, CAG, is our next codon. So that would be GUA. GUC, sorry, trying to do this live stream. That would be the next one that it brings in. It would form that peptide bond. Try to open up my peptide bond here. Form that peptide bond between the two, which would then free up this one to float away, and now it would keep moving along, forming your protein from that string of amino acids until it hits a stop codon at the end, and then your protein would be fully formed and hopefully able to be packaged and sent to where it needs in order to achieve its function. So that would be the full central dogma of DNA of biology, from DNA, double-stranded, to RNA, single-stranded, to our translation. Transcribe, translate, protein. Central dogma of biology. Hope that helps. Feel free to watch, feel free to ask questions. We'll go over it in class with a few activities as well. But this is our short and sweet video on how that all works. Thanks for watching. Have a great rest of your day.